Okay, great. So just to confirm, you can see my presentation. Yeah, okay, great.
Yes.
So, as you are probably already familiar with, Vibrant is the brand under Snap One, which is in charge for everything related to the lighting, and not just the LED tapes, accessories for LED tapes like extrusions and lenses, but also the active components like controllers, wired or wireless. So there are several ways how we can control the smart lighting. We can control it over different protocols, over wired protocols like DALI or DMX, or we can control it wirelessly over Zigbee. So why it is that important today that we have smart lighting built in into the home automation? Generally, smart lighting is today in modern homes quite important part of the overall system setup. It is not just today used for standard ambient lighting. It is used for task lighting, for to provide more brightness, more clear light for working areas, and also it is part of the interior design used as decorative lighting under the shelves, pointing out certain pieces of art, etc. So generally, we have three types of lighting: general ambient, task lighting for working areas, and accent lighting for the decorative purposes. So any kind of light and any type of LED tape, is it just white LED, is it colored LED, can be fully integrated and managed through the Control 4. So depending on the type of the light we would need to use in our project, we have different LED tapes which provides different features. The simplest LED tape is of course fixed color LED tape, where you have just option to change the brightness level of the color which is predefined. Furthermore, we have warm dimming LED tape. Warm dimming has option to control the temperature of the white color. Is white closer to the yellow part of the spectrum or blue part of the spectrum? But with warm dimming, we cannot independently control brightness and the temperature, because brightness is related to certain temperature of the white. So we use single channel to control both. Fully tunable LED tape, at the other hand, also controls temperature of the white, but with this tape, you can independently change the brightness and change the type of the white color. So those are all tapes which don't have any RGB color. RGB white and RGB tunable white, they support full color spectrum, so you can choose whatever color you want. The difference between those two is that with RGB white, you have fixed white, and with RGB tunable white, you can change independently the type of the white and to select any type of the RGB color on the LED tape. Depending on how many parameters we can change on the LED tape, each LED tape has a different number of channels in order to be fully controlled. So RGB tunable white would require 5 channels, while fixed color and warm dimming would require only single channel. Depending on the number of channels we have, we make the practical design of our system, because that directly affects what would be the optimal method and what would be the best device to control the LED tape from Control 4. So uh, depending on the LED tape, as I mentioned previously, we have single channel and multiple channel LED tapes. Generally, LED tapes work on 12 to 24 volts DC. Everything what we have under Vibrant LED tapes and the controllers as well, they work on 24 volts. So when we are setting up the Vibrant system, we are working on 24 low voltage system. So what tapes are single channel and what are multi-channel? Single channel are fixed color and warm dimming, and multi-channel LED tapes are fully tunable with 3 channel, RGB white with 4 channel, and RGB tunable white with 5 channels. So what is in general control of the white color? We express the type of the white color through the kelvins and call it like a temperature of the white color. Lower the kelvins, that means the temperature goes on more yellow part of the spectrum, and higher the kelvins, that means more blue part of the spectrum. Typically, LED tapes from Vibrant, they support range between 2700 kelvins up to the around 6500 kelvins. So we can completely cover that range of the white spectrum. On the other hand, we also differentiate different types of the LED tapes itself. Regular LED tapes will have discrete lights on the tape itself, which potentially can cause that you don't have continuity of the light. But generally, using the extrusions and lens, they will diffuse the light so you have continuous light without noticeable discrete LEDs on the tape itself. But if you would like to use like a fully diffused light from LED tape, there is also an option on so-called COB tapes, which are called chip on board, which have continuous LEDs along the tape itself, and that is like a specific LED tape. So as I mentioned, the two typical ways or fully controlled LED is to control the white using the tunable white, and RGB, where you through the three channels, red, green, and blue, mixing those three channels, you can achieve whatever color from the color spectrum you prefer. So depending on the customer requirements, we specify either fixed LED, either tunable white, or maybe RGB tunable white, whatever LED in the specific project. And based on the channel we use, we decide what should be the best way to control it. Beside of the number of channels, the control also depend of the medium which we use for certain LED. It can be wireless or wired. So we can differentiate different types of technologies, to say like that, which are appropriate for certain type of LED and certain type of medium. So first of all, we have for single channel LED tapes for wireless control, we have like a standard control for dimmer, because you have a single channel from there as well, and you can control the brightness. And that way, through the single channel, you can control fixed color LEDs or warm dimming LEDs. Also, what we have from like a relatively new product from the Vibrant product portfolio is DCM4, which is a 4-channel hub connected over Zigbee wirelessly to the Control 4 controller, and where you can connect up to 4 single channel LEDs. Just remember right now at the beginning that DCM4 doesn't mean that you can connect 4-channel LEDs. It supports only single channel LEDs, but it acts like a hub, which means you can have 4 independent loads, 4 independent LEDs controlled from single device, but they are all single channel. And beside wireless control, we have wired control. This is our traditional panelized lighting system, where you can control dimming on the lights connected to it, and it is consisted of wired keypads and 8-channel dimmer and relay modules. So that is single channel control. For more advanced LED tapes, where we would like to independently change the color of the white, or to change RGB color on the LED tape, we would need different controllers for wireless and for wired as well. So when we speak about wireless control, we have two devices there, two Zigbee controllers. One is DCM3, which supports 3-channel LED, up to 3-channel LED tapes, which means you can connect either one single channel, either one 3-channel LED tape, and that is practically fixed color, warm dimming, or fully tunable. And we have that is the maximum channel supported per controller, DCM5, with 5 channels, where practically you can connect whatever LED tape you have, but generally it is intended to be used for 4 or 5 channel LED tapes like RGB white or RGB tunable white. So just remember here also that DCM3 and DCM5, they are always single load. So you cannot combine multiple LED tapes on a single controller. In the user interface, in the Control 4, they appear as a single light. While, for example, DCM4 appears as 4 lights. So DCM4 is 4 times single channel, DCM3 is 1 3 channel up to 3 channel, and DCM5 1 up to 5 channel LED tape. So that is wireless multi-channel control. And on the wired multi-channel control, we typically used one of the two protocols. One is DMX and the other is DALI. And for both DMX and DALI, we have all the components for the ease integration with the Control 4. So today I will speak in more details about wireless control and how we integrate our LED tapes wirelessly to the Control 4 using Zigbee protocol. So first of all, the smallest controller we have, the smallest LED tape controller communicating over Zigbee is DCM3, as it supports up to 3 channel LED tapes. So the size of this controller is really small. As you can see in the picture, it can be placed in the same tray like LED. So you do not need to think about specific location of this controller. It is just put like a part of LED tape, and it, as you can see, it looks like this. So really small and convenient for any placement. On one side of the controller, you have 24-volt DC input powering up the controller and the tape, and on the output you have 3 channel. That means like a 4 wires. One is for voltage, and 3 wires controlling LED tape itself. So installation is quite simple. You just need to wire up to the 24-volt power supply and connect the LED tape directly to the controller. So this controller can support fixed color, warm dimming, and fully tunable white LED tapes, which are using up to 3 channels for full control. Like any other device on the Vibrant, this controller is also 24-volt. And just remember that when adding this controller in the project, it can be just like a single load, single light. What is also important regarding the DCM3, just to know that DCM3 is our smallest controller. Comparing to DCM5 or DCM4, it is much smaller, and it is really convenient for the installations where you are quite critical with the space. As it is Zigbee device, the adding a DCM3 controller into the project is the same like with adding, for example, adaptive phase dimmer. You have ID button here. You can see it on the picture here. You have ID button, and just by pressing it 4 times, it will be identified in the Zigbee connections in Composer, and that is all. It is ready to be used within the Control 4 system. Okay, so next Zigbee controller is DCM4. DCM4 controller is in fact a small hub connecting 4 independent loads using the single device. So it also works with 24-volt power supply. And when you add it to the project, and I will show you later that in Composer, DCM4 driver as DCM4 is not appearing as a lighting load on the user interface. So it is just a hub with available connections for the DCM4 light channels. So when you use the driver for the DCM4 load and add it to the project, that light will appear as a lighting load in the user interface. So it is not like DCM3 or DCM5 that when you add it to the project, they immediately appear on user interface as controllable load. DCM4 by default is not visible by end user. You need to connect additional drivers for each of the channels in order to control them from the user interface. So it has practically four independent zones, and just remember those four zones are single channel LED tapes. So it just supports fixed LED tapes, warm dimmable, and that's it. So you cannot change through all those LED tapes. You cannot change color, or you cannot change independently brightness and temperature of the light. Okay, so and the last device for wireless control of LED tape is DCM5. DCM5 is intended to be used in projects where you have RGB LED tapes, which require at least four channels for single LED tape. It also works, of course, on 24-volt DC, and it would require uh, some part like all the others, some power adapter on 24 volts, which we also have available from the Vibrant product portfolio. uh, it is important to point out again that DCM5 is appearing as a single lighting load. That means those five channels are always single load. You cannot split them across multiple LEDs. So one DCM5, one load, one lighting load to control from user interface. Typically, five channels for example, RGB tunable white are used for red, green, blue, warm white, and cool white for the RGB tunable white LED tape. That doesn't mean that you cannot configure DCM5 to work with three channels, for example. But I would say it would not be cost effective to use DCM5 for three channels LED because you have dedicated DCM3, for example, controller for that. So typically you would use DCM5 either for four or five channel LED tapes, and it is fully configurable on the driver for DCM5. And I will show you that later how it looks like in the composer. Regarding the identification in the Zigbee connections, it is the same like any other Zigbee device. You have ID button, press it 4 times, and it communicates with the Zigbee server, which is a Control 4 controller, and automatically it is integrated within the Control 4. So those three devices, DCM3, DCM4, and DCM5, they are practically all controllers we have available for wireless control of LED tape. And practically depending on the number of the channels we need to support from LED tape, we choose one of those three to connect LED tape to and to manage it from the Control 4. Okay, so as all those three controllers are using wireless Zigbee protocol in order to communicate with the Control 4 controller, it is really important that we provide reliable wireless communication between Zigbee access point, which is Control 4 controller, and the lighting controller itself. So everything what in general stands for any wireless connection like Wi-Fi stands for Zigbee as well. In fact, Zigbee and Wi-Fi operate in the same frequency band, which is 2.4 gigahertz. Just Zigbee as a protocol, it has some specific characteristics which are different comparing to the Wi-Fi. The most important thing about Zigbee is that it is meshed network. That means any node, any Zigbee device in the Zigbee network is acting not just as a receiver but also as a repeater. That means more Zigbee devices we have within a single Zigbee network, our network is more stable because we have more nodes to exchange data one with each other, and practically we have better coverage that way. But there is, of course, limitation in the number of nodes which we can have per single Zigbee mesh, and that is 70. So always have in mind that you don't have more than 70 devices within a single Zigbee mesh. Also, historically, with the Control 4, we had options that you can share single Zigbee mesh across different Control 4 controllers. That is changed maybe 3-4 years ago, and now always one control for controller is one Zigbee mesh. The other control for controller is the other Zigbee mesh. So you cannot have one Zigbee network distributed across multiple controllers. So when you are designing maybe bigger network, a bigger Zigbee network across wider area, it is important that you take into consideration what Zigbee network is belonging to what control for controller. It is the best practice that it is clearly obvious what devices should be attached to what control for controller and as a Zigbee nodes. That means you should avoid two control for controllers acting as Zigbee access points too close one to each other, or having devices in between, so device is not sure should it connect to the first or the second Zigbee mesh. So each control for controller is mesh for itself now. Of course, as a control 4 controller is acting as Zigbee access point, it is for a good and reliable Zigbee communication. It is really important that we have good visibility between control 4 controller and the Zigbee nodes, like lighting controllers. So that means that the worst case would be to put and use control 4 controller as access point from basement or from rack or from any other closed metal environment, because it kills the Zigbee signal completely. So just have in mind that placement of the control 4 controller acting as Zigbee access point is crucial to good Zigbee communication. Typically, if we have larger projects, we would use some uh, controller like CA10 or maybe Core 5 acting as a director, and it will be placed in a rack. Definitely, that is not a good choice to use that controller for Zigbee access point. Have in mind that bigger controller, more powerful controller, doesn't mean it has more power for the Zigbee connections. So when Zigbee serve and Zigbee access point is in question, controller is equally powerful regardless to its size. So CA1 is equally powerful Zigbee access point like Core 5, for example. So generally, it is not a good practice to use director, which is most commonly in the rack, as a Zigbee access point. Typically, Zigbee access point should be some controller which is located in the room, which is relatively close to the lighting installation. That means relatively close to the lighting controllers. So we have good close interaction between Zigbee access point and Zigbee lighting controller. So in situations where we have set up like that simply by our standard control 4 design, we don't have any controller which is ideal candidate for a Zigbee access point. Maybe everything is in rack, or a room where controller is far from the place where Zigbee controllers, lighting controllers are located. In that case, I would suggest to use a controller just as a Zigbee access point. And the most easy way to, the most practical way to achieve this is to just place one CA1 close to lighting controllers, and the main purpose of that CA1 would be just to provide Zigbee coverage for the light control. So CA1 can be placed as a Zigbee access point just for that purpose, and to provide secure and reliable Zigbee communication with lighting control. So when we speak about wireless communication, coverage and access to the controller is just one part of the design consideration. The other part is related to interference. Zigbee protocol, as any other wireless protocol, it relies on the significantly on the clear channel communication, depending on the channel used to connect to lighting controller. As Zigbee overlaps with Wi-Fi and 2.4 gigahertz, ideally we should use channels from Zigbee which are not in use on the Wi-Fi, or channels on Zigbee which are between the typically used channels on Wi-Fi. So as you probably already know, on Wi-Fi on 2.4 gigahertz, we use channels 1, 6, and 11. And because 1, 6, and 11 are creating interference for Zigbee, we would use some Zigbee channels which are not overlapping with 1, 6, and 11. In this case, those are channels 15, 20, and 25. So channels 15, 20, and 25 are ideal candidates to use for Zigbee communication in Wi-Fi environment. And generally, every home today would definitely have a Wi-Fi. Just we do not know what channels are used. So based on this diagram, you can see if channel, for example, 1 is used on a Wi-Fi, you can use channels from 15 and above for Zigbee because you don't have interference from the wireless. But generally, if it is a bigger network, you would for sure use all three channels, 1, 6, and 11, just for a Wi-Fi. And in that case, the best would be to use channels 15, 20, and 25 because they are in between of typically used channels on 2.4 gigahertz on Wi-Fi. So as you can see from this diagram, the transmit power on channel 25 is slightly lower comparing to channel 15, channels 15 and 20. So channels, because of that, channels 15 and 20 would always be our first choice, and only 15 and 20 are already used or we have high interference already on those channels, we will go on channel 25. But just have in mind that with channel 25, due to lower transmit power, we will always have slightly lower coverage comparing to channels 15 and 20. So we need to be sure that Zigbee access point, that means control for controller, is close enough to the Zigbee devices to provide reliable connection. Okay, so that is related to the best practices regarding the wireless setup and wireless communication. So we need to take care about the placement of the Control 4 controller acting as a Zigbee access point, and we need to take care about the interference when we select the Zigbee channels to use channels which are free from the communication. The other part of the lighting design, and it is general for any lighting, not just for the wireless, is power. So as you know, our LED tapes and also Zigbee controllers, they work on 24 volt. So you would use one of the power adapters, one of the power supplies, depending on the power budget you need to cover. So we have different models available from 30 to 300 watts, 24 volt power supplies. And the one which you use depends on the power budget which you need to cover. Just have in mind that it is bad practice and avoid to specify the power supply which perfectly fits the consumption on the project, because it is not a good practice to fully utilize power from the power adapter. It can easily cause some overload. So always specify to use just 80% of capacity, of specified capacity from the power supply. So that means if you use 200 watts power supply, we wouldn't use more than 160. And for example, for 300 watts, we wouldn't use more than 240 watts from that power supply. Okay, so regarding the power, it is also important how far our power supply is from LED tape itself. That means how long are the wires connecting the power supply and the LED tape. So because each wire will introduce some voltage drop, which is higher as length of the wire is longer. So in order to properly design the wiring length against the LED tape location, we need to know what is the voltage drop from specific wires we use and calculate based on that, based on the voltage loss index, calculate what is the optimal wire thickness for specific length in the project. Have in mind that always thicker wire means less voltage drop on the wire itself. So general rule is if we have longer wires, we use thicker wires, and if we have short wires, they can be thinner because voltage drop is not that critical. Ideally, the power supply and the LED tape would be as close as possible, but in real-time environment, that's really hard to achieve. So always choose for longer distances thicker wire for set it up. Also regarding the power, we have one important parameter specified for each LED type, and it is called the max run. That means what is the maximum length of the LED tape without power supply. So this parameter tells us after how many meters we need to do a power injector in order to keep equally powered whole LED tape. So different LED tapes have different max run. For example, for tunable white it is 5 meters, and for RGB tunable white it is 4 meters. That means for RGB tunable white, each 4 meters we need to have one power supply just to be sure that the LED through whole length is equally powered, that we don't have any voltage drop within LED tape itself. So regarding the wiring, as I mentioned, the thicker wire is used for longer wiring, but some typically use the gauge for the power supply of LED tape is wire around 0.75 up to 1 millimeters for, let's say, maybe up to couple of meters. If it is longer, then we definitely should go with thicker wire. Okay, so that is covering that hardware part. So when we are speaking about design of the lighting and smart lighting, definitely, especially if we are speaking about wireless, we need to think about position and the power budget of the power supplies for that system, how wiring will be done, and what is the gauge of the wiring to provide optimal and to have less voltage drop in the system. And also, as it is wireless system, we need to think about coverage and interference to have reliable communication. So how we integrate our smart lighting into the control form? So I would say that the hardest part is just to set it up, to design wiring, power, wireless communication. When that is all done right, the integration within the control form is quite straightforward. So in Composer, you have, of course, the drivers for each of three Zigbee controllers, DCM3, DCM4, and DCM5. And within the driver setup, you have options to select how many channels they use. And depending on the LED tape you have, you select the proper one and you get the channel available for that LED tape. Of course, on each controller, you have marked what output is what channel from controller itself. So I can show you on Composer how it looks like. So here, for example, this RGB tunable white, that is my DCM5 controller. And as you can see here, you don't have a lot of options to set up. And the most important is to select what LED tape you use. So you just select it from the drop-down menu. And in this case, I have RGB tunable white. So when I select RGB tunable white, I get 5 channels available. If I select some other LED tape, I will have less channels. Let's say, for example, if I select tunable white, I will have just 3 channels here. So I can say channels 1, 2, and 3, for example. So by selecting the LED tape type, you get the channels for that LED tape. Typically, as I mentioned, it only has sense to use DCM5 for 3 and 4 channel LED communication, because for 4 and 5 channel LED communication, because for 3 and less we have controllers with less channels available. When you add RGB tunable white in the project, on the user interface, you will see that driver as a single load, like here. So this is my DCM5 controller. So it is like I had directly added light into the user interface, and of course, as it is RGB tunable white, and customer can fully change the color either to preset list, either through the color selection. You select from the color spectrum the brightness and saturation, and also as it is tunable white as well, you can choose the temperature of the white and the brightness. Of course, when you select the color, if you have your favorite color, you can easily save it as a preset like this, and it will appear in preset list, so you do not need every time to manually search the color and set it up. It just appears in the preset list. So it is quite straightforward from the user interface. As you see, when I add the driver in the composer, it automatically appears as one lighting load on the navigator. So let's go back here just to show you the DCM4. If you remember, DCM4 controller, it is hub with 4 times single channel LED. So when I add DCM4, I need to create connections to DCM4. It has 4 channels available, and I need to connect one lighting load, and it is like a single channel lighting load to each of the connections of DCM4. The driver used for that is DCM4 channel. That's the name of the driver which you need to connect to DCM4. And when I connect that driver here, it appears here in user interface DCM channel 1, 2, 3, and 4. So just remember that DCM4 as a controller is not appearing as lighting load, but the drivers connected to it. Okay, regarding the initial identification of controllers, it is the same like for any other Zigbee device. So you go to connections, you go to network, Zigbee network, and here when you add the driver, you just do like a double click on the driver, and then you press ID button 4 times. And when if Zigbee communication is good, if everything is okay, MAC address of the Zigbee controller will appear here, and just by confirming it, it will be assigned to your Control 4 controller. So as you can see, it is that simple, just identification of the Zigbee device, and after that it is available as a lighting load in your system. Okay, so that is all regarding the integration with Control 4. As you can see, it is quite straightforward. And let's check now some example of the wireless lighting design. So what is important when we start designing our wireless lighting project? First of all, we need to check the parameter which is called power consumption of the LED tape. Different LED tapes, they have different power consumption. For example, RGB tunable white, it has 23 watts per meter. Depending on the total length of LED tapes, we can estimate what power budget we should have in order to have our LED tapes having the proper power supply. Beside that, it is important to know what is the limitation of each controller. Each controller has maximum power which it can provide for connected LED tape. So for example, for DCM3, it is 100 watts. For DCM4, it is 160 watts per channel. And for DCM5, it is 196 watts. So always have in mind that LED tape connected to the single controller cannot be longer than maximum power available from that controller. So in this case, if I have like 23 watts per meter, and my maximum power available from DCM5 is 196 watts. That means I cannot have maybe more than 80 meters of LED tape, of RGB tunable white LED tape connected to the single controller. So if I have a longer tape, I need to use more controllers to be able to control that LED length. And of course, at the end, I mentioned that previously, we need to take care what is the max run length of the tape. And for RGB tunable white, that is 4 meters. What does that mean? That means that I need to take care that LED tape every 4 meters, it has power supply injector brought to the LED tape itself. That doesn't mean that I also in that place need to have Zigbee controller. But that means just that I need to have additional power brought to the single place. That means any point on the LED tape shouldn't be further away than 4 meters from the closest point where I connected power supply. So there are different ways how we can bring power to LED tape. The first example here is that we bring LED power supply at the beginning on the LED tape and on the end. So this way we can have up to 8 meters long LED tape because we have 4 meters from this side and 4 meters from this side from the power supply. So total segment can be 8 meters in this case. Also, you can bring the power supply in the middle and at the end, or in the many segments on the LED tape itself. Just it is important that any part of LED tape is not further than 4 meters to the closest power supply. So that is important thing what we need to consider when we are designing longer LED tapes, to be sure that max run length is not exceeded from the closest power supply. Okay, so let's see one example. In this case, we have a project where we need to use RGB tunable white LED tape with 40 meters. If you remember on the previous slide, the power consumption of this LED tape is 23 watts per meter. So if I have 40 meters, my LED tape, just LED tape, would require 920 watts to have fully covered LED tape with the power supply. So as max run length of LED tape, RGB tunable white is 4 meters. That means I have to split this 40 meters into 10 segments of 4 meters, each having one power injector for it. How we can do it? We can use, for example, 5 times 8 meter segment, and power supply will be at the beginning and the end of the tape, like in this example. So this means there is no spot on this LED tape which is more than 4 meters further away from the closest power supply power injector. So we can use, for example, 5 times 8 meter segments with power supply on the beginning and the end of the LED tape. Okay, that's clear. So let's check what is our limitation when controller is in question. As this is RGB tunable white, that means I have to use my 5-channel DCM5 Zigbee controller. So each segment of 8 meters would have 8 times 23 watts, which is 180 watts. My maximum power utilization from DCM5 is 196 watts. So this is within that limitation. So I can use one DCM5 per each segment of 8 meters, and I'm good. If this power consumption is higher than the highest supported power consumption from DCM5, I would need to split these segments into smaller segments. So that is the second condition which needs to be fulfilled. And at the end, I need to say how many power supplies and what type of power supplies I would need. As I have 5 segments, I will use 5 different power supplies, and I will use the biggest power supply of 300 watts. 80%, which is recommendable way to use it, of that is 240 watts, which I will have available per each of the segment. 240 watts is higher than 184. That means one power supply of 300 watts would be enough per each segments of 8 meters. And that way I conclude my design. I need 5 times 300 watt power supply. I need 5 DCM5 controllers, and I need 40 meters of LED tape. And how I will wire it? I will wire each LED tape at the beginning and at the end from the power supply. And that's it. So it is quite important that when you are designing LED tape and when you are designing the setup, you always calculate the power which you need and the places on the tape where power injectors would be in order to have proper setup. Okay, so also, what I would like to mention related to maybe in general to Vibrant is daylight agent. This is the most typically used agent in residential projects because it is controlling the tunable white and it is synchronizing the temperature and the type of the white color with part of the day. So it is quite important because it provides more natural light in the room, and it provides the restful sleeping environment in the evening, and it is in accordance with regular wake schedule. And that is something what is most commonly used in the residential environment. When we speak about daylight agent is fully accessible. Management and setup is fully accessible from the user interface, and also you can set it up from Composer. Of course, first what you need to do, you need to add that agent in Composer itself, but any further setup can be done by the end user through the either touchscreen or through the Control 4 application. So what Daylight Agent does, it has 3 points during the day, morning, midday, and evening, and it automatically changes the temperature of the white based on the parameters you give to be in accordance with the sunlight. So it is more yellow during the morning, during the evening, and it is more bright at the midday. So it is practically following the sun that way. This screenshot is screenshot from the Composer, where you as installer can manually define the brightness and white temperature for the daylight agent for these 3 points. But generally, when you just enable the daylight agent and set up the times, you will have some default values there already. So you can customize it, but you do not need it because there will be some predefined values already there. When time is in question, typically we do not set up time manually because every day sunrise and sunset are a different time. So it is enough just to select the location, and system by location and the date knows immediately when is the sunrise and when is the sunset, and dynamically changes it every day so it is in accordance with your location. So I can show you how it looks like on the user interface. So it is like a third tab under lighting section. So everything what end customer needs to do is to add it here to select the room where it is used. within the room you will have all the lights which are supporting at least tunable white, for example DMX, and I can select daylight agent to be scheduled based on fixed time or based on location. It is not that feasible to use the time because it is changing every day, but you can do it if you want. Typically we use location, and here we can place our location. I don't see Spain here.
First A.
Yeah, maybe it's because the accent. The first A has an accent.
Aha, maybe to put like this. That would be
Yeah.
easier. Okay.
Easier.
Yeah. So cycle settings, this you have some predefined values that is related to brightness and temperature, but as you can see, you can change it if you want. And finish. And at the end, you can put the name, and you can select this from the program here, Madrid. So you can immediately see when is the sunset for this date, and when is the sunset, when is the sunrise, and it will change the temperature of the white automatically this way. At any moment, end customer can change it in the options. It can change, for example, values for the brightness and temperature of the white. So it is most commonly used with any tunable white color integrated with the Control 4. Okay, so that covers all what I prepared for today. Do you have any questions for me?
No, I had before your explanation a question about the CA1 because I appointed initially
Mhm.
about the CA1 using it as a Zigbee
Access
repeater
point.
because
Mhm.
yeah, because we have an installation with EA1, but it's broken down, it's out of warranty. The idea is to replace the EA1 because actually the partner is using that as a Zigbee repeater, and the idea is move it with the CA1, but
Yeah,
you
so
respond me before.
if it is using just as a Zigbee, if you don't use any kind of like audio video services from there
Absolutely,
through
yeah, yeah,
HDMI, I don't see a reason why you would use EA1 there. So
yeah, yeah.
CA1 would be a
Okay,
perfect replacement. Yeah.
okay. This was my question, but you answered me before.
Okay. Any further question, maybe?
For me, it's very clear. Everything
Okay,
very
great.
well
It's
explained.
very clear.